Now we will discuss something about law of diminishing marginal returns. Law of diminishing marginal returns. Now when I talk about marginal, again it is incremental, right? So it can say that as the use of an input increases in equal interval or equal amount, a point will be reached after which the resulting additions to the output will decline. That means if I go back, here we can see in this, we can see there is a point at which my average product or my total product has increased, after which it has started declining, right? So basically the MP, when it starts falling, then we will see, because why we say MP, why not total product? Because we are saying that when my input increases by one additional unit, the additional contribution to the total product, the additional contribution to the total product, that is my marginal product, starts declining. Yeah, so that is diminishing marginal return. Now return, we say that what is your return? How much is the return? That means how much output, how much outcome you are gaining from something. What is the return you are gaining? Marginal return is similarly marginal output or marginal product. Now diminishing marginal returns means diminishing marginal product. So naturally here, when we talk about diminishing marginal return, we don't talk about the point where the average product or the total product is decreasing. We are basically talking about the point where the marginal product is decreasing. So when MP declines or decreases after reaching a certain point in the production process. Yes. So generally, when the labor input is small, when I have lesser number of labor at the initial phase of, now it can be labor, it can be capital again. Why we are talking about labor? Because we have taken the example of labor, we are continuing with that. So when the labor input is small, the marginal product increases because of the labor specialization. When there are only few labors, so I have chosen those few labors based on their specialization, that I know that they are specialized in these areas. So even if I have a small amount of labor, they are so specialized that they can, they can run the show on their own, right? So when the labor input is small, marginal product increases due to the labor specialization. I will note it down. When labor input is small, MP increases because of labor specialization. Yes, the second point is when the labor input is large, MP decreases due to inefficiency. When labor input is large, MP, marginal product, decreases due to inefficiencies. Too many cooks spoil the food. Too many cooks spoil the food. So, if I have too many labors, then, and we have seen, in several public sector units, we have seen that there are too many labors than it was required, and what happens is they just don't produce at the efficient level, and the cost of that production process is so high that after sometimes they run out of the business, they cannot continue, right? So we need to decide, we need to remember that what is the number of labor. Yeah, we need to keep to continue the production process. The law of diminishing return can also be used, diminishing marginal returns, not diminishing return, better to say diminishing marginal return, so that we remember that it's actually the marginal products is declining. We can also decide that what should be the trade-off between different configuration or different bundles of labors on capitals or different inputs. What can be the trade-off, that how many capital and how many labor in the long run where I can change both the capital and labor, right? In the short run I cannot, but in the long run I will certainly be able to change. So this law of diminishing return, if I can point it out as a third point, it helps us, apart from those two, that when my labor input is small, I have to keep in mind that I have to get specialized labor. When the labor input is large, I have to keep in mind that there is no inefficiency. At the same time, at the third point, it helps us to identify the trade-off between different plant configurations. Yeah, and it eventually assumes that the quality of the variable input is constant. When I continue changing the number of inputs or increasing the number of input, I am actually getting the same quality input. So it's not varying. So when I am increasing labor, more and more labor, the quality remains same. Yeah, there is no variation that the next labor is extremely capable, or he is tremendously incapable. No, it's nothing like that. Yeah. So the quality of the variable input remains constant or same. Yeah. The fifth point can be, it explains a declining marginal product, not necessarily a negative one. If you know that the number of production is not going to go down, it's not marginal product is negative. So when we go back to our this slide, this entire area is determining or discussing or talking about the decreasing or diminishing marginal returns. Not necessarily it is eventually this, but not necessarily this part. Yes, it can be this part where it is just declining, even if it's not going to be negative. So not necessarily the negative part of marginal product curve or marginal product schedule. Number 6 is, it assumes a constant technology, right? That's the assumption we took when we started discussing about production function, that it assumes a constant technology. Whenever we change any factor of production, the technology never changes, so it remains constant. But if we consider that there is a technological improvement, what happens? What happens to the total product curve? If there is a change in the total product curve, and due to pertaining the technology, over here this is my total output, total product, and in the x-axis I mentioned my labor input in a given period of time. And if my production process is something like this, smoother. Yeah. So with the production process, improvement in production process, it gets shifted in a pivoted manner. And we can see that with the same amount of labor, they are almost reaching the highest point at the same period of time or with the same amount of labor. But the total product curve has shifted upwards from 1 to 2, from 2 to 3, which shows the amount of production with the same amount of labor, even if they have reached the maximum total product, after which the total product goes down. With the same amount of labor they have with all three different technology, they have with those many labors, they have achieved the maximum. After that it's same. After that they go down. But what is different is the amount of production which is being produced. So when technology changes, there is a pivotal upward shift of this total product curve, pivotal, because all of this starts from the origin, no input, no output, right? This starts with the origin mostly, mostly. And then at least we can assume here that it's happening like that, and then it goes through a pivotal shift. Thank you.